Hello, everyone. Welcome to Cataloging Cocktails. It's your weekly live hangout, an honest, no BS, non-salesy conversation about enterprise data management with tasty beverages in hand. I'm Tim Gasper, longtime data nerd and product guy at data.world, and joined by my co-host, Juan.
I am Juan Sequeda. I'm the principal scientist at data.world, and it is Wednesday afternoon. It is that time where we're going to take that quick break and talk about data. And today we are having Drew Banin, who's a co-founder of Fishtown Analytics. And Fishtown Analytics, they're the popular kid on the street. They're the folks behind DBT, and they're truly disrupting the whole data transformation process, the T and ETL. If you have not heard about DBT, you've literally been underneath the rock in this data world. So, Drew, how are you doing?
Hey, Juan. I'm great. Thanks for having me on today. I'm excited to be speaking with you.
Awesome. So just as a quick reminder, check out our new website, data.world/podcast. Follow us on Twitter. We're the honest, no BS data, and on LinkedIn. Give us reviews on Apple Podcasts and follow us on Spotify. Join our Slack community at slack.data.world, and we want everybody to share your takeaways. So let's kick this off. So again, what are we all drinking and what are we toasting for today? Drew, how about you kick it off?
Yeah. So this is a really great glass that my coworkers got for me like 3 years ago. There's three men on it, and they said that I'm this one's Tristan, this one's Connor. It's called the Founders Cup, and we each have one. So this is a special glass for me. I'm not a huge cocktail drinker. I actually prepared I took out a bottle of beer from my fridge, and I thought, that's cataloging cocktails. I can't bring a Yard's Pale Ale. So I was saying before, I just mixed everything I could find in my freezer and cabinet in here. I guess I'll give you the rundown. So I'm a person who wants to like Negronis, but I do not at all like Negronis. I think I've never had like good vermouth, and they're just not for me. But I like the spirit of it, like spirit, get it? And there's a good spirit called Cappelletti. It's kind of like Campari. It's a little bit like Campari and a little bit like Aperol, but like maybe sweeter. So I put a little Cappelletti in there and gin, and topped it up with seltzer, and I had some like lemon simple syrup sitting around. So I just throw it all in.
That sounds pretty good. I've actually never tried Cappelletti before. I like Negronis a lot, and I like Campari, and I'll have to put that on the list to try.
Yeah, it's really good.
Well, I'm the complete opposite right now. I am just sipping on one of my favorite rums. It's a Rum Zacapa 23. I think is the best rum in the world, and I think if I were to add anything to this, it would be bad. So I'm enjoying just sipping on this rum today. How about you, Tim?
That sounds pretty good. I am using this fiery ginger syrup from Liber & Co. And I made like a spicy ginger rum fizz kind of thing. It's got some topo in there and some lime, some black rum. It's pretty tasty. So,
all right. So what are we going to toast for? Somebody throw us something out.
So I can tell you that yesterday was DBT's 5th birthday, the 5-year anniversary of its first commit. So I'll drink to that.
We definitely have to go toast to that.
That is fantastic.
Cheers. Cheers. Well, post in the chat. Tell us where you're coming from. What are you drinking? What are you toasting for? But we got our warm-up question, which is we always get this out. So if you could transform into any animal on the planet, what would it be and why? Tim.
I feel like this is a hard question. I like being a human. I don't know about you guys. So like when people ask this question, I feel like some people are so quick to be like, oh, I want to be an eagle or something like that, you know? Like
mine is simple. I like to be a dog. You just take it easy and just sleep.
Yeah, that's a good one. That's a good one. I guess I would fly. I'd be an eagle, sure.
I have a tough relationship with this question in that when I think about animals, the one that comes to my mind first is a snake. And I hate snakes. I'm viscerally afraid of snakes. And they occupy such a central part of my brain that when you ask me that question, I immediately think like, oh, remember snakes? You're afraid of them. And so I almost want to say like, I want to better understand snakes. I don't want to be afraid of them. I don't think I'd want to be a snake forever, but if this is for like a day, if I could tolerate it, I'd like to get inside the head of a snake and be a snake and be less afraid of them.
That's a profound answer.
Yeah.
I mean, you have your
great,
you've thought about your cocktail, but you've thought about your answer here. But now let's talk about data.
Scientific data.
So I want to get this off, and I was just talking to Drew before we started this. Honest question. Why the heck did it take so long to come up with something like DBT? We've been doing ETL for over 3 decades. It's the same stuff over and over again. Why now? Why is it now finally happening? I want to know this.
Yeah.
Yeah, please
Okay.
go.
Two-part answer to this. I think the first one is there have been many versions of things like DBT before DBT even came into existence. I built one of these when I was an intern in college at a company called 8Tracks. It was like a Ruby script that generated SQL, and it actually ran on Redshift. We've spoken to tons of people and organizations who have built things like this before, and they're always ad hoc and sort of poorly maintained. And I think part of the electricity around DBT is that people like the concept and don't need to maintain it themselves, which is, you know, a sort of good place to be in if your core competency is not building data transformation tools. But I'll also say, like, there is a bigger shift from sort of the ETL model that you described to this ELT model. I think that's totally powered by the data warehouse. And I would point to Redshift really primarily as being the original game changer. And then BigQuery and Snowflake, from our perspective, increased in adoption after that. And now we see like Databricks in the mix too, and many others we can talk about. But I think ultimately, like, that's the thing. And specifically, if I was to point to something about the modern data warehouse, it is flexibility. I think with a lot of old like appliance-based data warehouses, you would need to pre-provision a lot of storage and compute, and it made you want to do a lot more upfront transformation so that you didn't have spiky usage characteristics within your data warehouse that was very expensive and very rigid.
So is it that our pipelines are becoming more complicated, and that's why we need to have more tools? Like, that's why we're realizing that we need to have more tools, like make this more first-class citizens. And just before, ETL wasn't as data warehouses weren't as complicated. And then aren't complicating ourselves too much? Like, does it really have to be this complicated? Because that's what scares me.
Fair. I think the most sophisticated thinker I've ever met on this topic was resistant to DBT. She was one of, like, from my perspective, the premier, like, I want to say SSIS developers on the planet. And everything I was talking about is new and innovative. She was like, I was doing that 15 years ago, and I was doing it in SSIS, and I don't care about your tool. And I thought that's really fair. I respect your experiences. I think it's always been complicated. I think that the shift happening these days is who does the work and how the work is done. Very quick plug is that I talked a little bit about this at my talk at Coalesce last December. We sort of are taking this work that used to be done by like a siloed group of human beings in a siloed data sort of, say, database or data storage mechanism, whatever it might have been, and sort of federating it out and saying data is less of a service where you must request things that are very rigidly specified, and instead you have a lot more flexibility to say, let's just load all the event data in the warehouse, and then we'll model it based on how important things feel. And so it's that shift towards flexibility that in some ways makes things feel more complicated, but also people are doing stuff with DBT today that would be really challenging to do in sort of the older school ETL model on more legacy products.
Yeah, that makes a lot of sense. It's interesting how you position some of the paradigm shifts around, you know, the modern data warehouse as you're talking about it. And, you know, obviously this is all part of a lot of new technologies that people are focusing on, whether it's cloud-based tech or just in general, more modern tech. You know, when you think about data lakes, data lakehouses, next-gen data warehouses, there's so much terminology flying around. You know, what's the right stack going forward? You know, what is the quote unquote modern data stack, and, you know, how do things like DBT fit into that? Well,
I want the honest answer here, right? I want to see what are your thoughts from the different things that you can go combine, because look, we had last week a conversation about data observability. We had with Monte Carlo, we talked about data testing and things like great expectations. At the end of the day, it's like, I could add all these other things into it. Like, do I need all these things? Like, what are the best practices? How to start? How to grow? Like, I'd love your perspective on this.
Yeah, Okay, my original answer was going to be that I think Shakespeare said there's no data warehouse, either good or bad, but thinking makes it so. But I'll give you something more concrete. I don't know, that the question about data warehouse, data lake is an interesting one. I think that there's a great, I'm supposed to say like unification happening where these lines, from my perspective, are starting to not really matter that much. If you use a tool like Snowflake, you can load data into Snowflake directly, treat it kind of more like, I don't know if I'm going to misuse the word appliance, but you can push data into Snowflake and not care about what that means under the hood. You can also stage a lot of data in blob storage and then query it via Snowflake stages or external tables. And so like, if the interface is you write SQL queries, it doesn't matter to me so much if you're selecting from a table or an external table or a stage. Like, it's kind of an implementation detail, and you probably the thing to think about is like cost primarily.
Are the trade-offs actually getting a little less severe, would you say?
I think so. I mean, I think this matters the most for very, very large data sets, where the really awesome thing about Snowflake, BigQuery, Redshift is that if you are in sort of the 95% of companies with regards to like data volume, it really doesn't matter that much. Like, it's going to be cost effective if you're paying like blob storage costs to store the data. And it's going to be pretty cost effective to query it unless you're doing like really interesting things like serving up an application, for instance, and you have like interesting query patterns. So I think the thing I would say is like, still, it matters how you write the data out. I think one way to get into trouble is to try to do a data lake architecture and not think about how you're writing that data and how it might change over time. That can kind of be a mess.
So that's the issue of semantics, right? That for me, the transformations are a representation of what the data actually means. So if like I see a data in the lake warehouse, whatever, is like, well, what does that actually mean? The semantics, the foundation of that is that transformation. And the thing is that this transformations usually get lost in some scripts, or it's in some proprietary SIS tool, or some Python people did. I think what I really like is about DBT is that because you're building everything on SQL, right? You're using that you have a declarative language to create these mappings, right? For me, all these transformations are just rules, and rules are mappings, and mappings are queries, and so forth. So all the same. And that's what really defines the semantics for that. But one of the things I do worry about is that how much of work is being reinvented. So how many people are doing transformations over and over again? One, and how many of them are actually slightly different to the point that the semantics are different? I look at the column or the table and the names are the same, but in reality, they are not the same. They mean different things because the transformations that were used to go build those mappings, we don't know what they really are, right? I think so. How do you manage all these things when you have a bunch of transformations, a bunch of people too? Because this is people work.
Yeah. Well, it's a good question. I think that the way you described it feels like a big problem. The thing I'm trying to reconcile is that it doesn't feel like a big problem in our organization or to the people that I speak to that use DBT. Not that it's not an intractable problem, but like DBT is intended to, in fact, solve that exact problem. It kind of is like the thesis, right? So the way we think about it is that the source data loaded into a warehouse, we call it source conformed. And so it's in whatever format your application emitted it. If you're ingesting data from your application database, maybe it's like SAS data, like say it's ad spend data, whatever it might be. That data is going to be in a shape that your source produces it in, and your source doesn't know anything about your business. Your source knows about like ads or your application or whatever.
It's an application-centric database, right? The source is there to go run for the application, not for your business.
So when I think about the sort of transformations that folks do, it's about taking that source data and mapping it into the language of the organization. And so for us, we talk about clients, like DBT Cloud accounts, we call clients or accounts. It has a different name for legacy reasons when we ingest it out of our application database, but like nobody outside of the engineering team knows that name or knows about the tables and their schemas. We wanted to think about things in terms of just say accounts. So it's actually that process of really defining what you mean by your sort of informal language. Like when I'm talking to someone on my team about self-service accounts, what we mean is accounts in DBT Cloud that are on the team tier in dbt Cloud or the developer tier. So you're like paying as you go. It's $50 per user per month if you're on the team tier, free for one user if you're on the developer tier. When I say self-service accounts, we sort of mean like a very specific thing. And that's the language that we used to talk about in our business. And you can drill into that. You can understand what is a self-service account. What do we mean by this sort of definition of like a data set ultimately, or a concept? And the thing about DBT is you get to define that logic in SQL. You can document it, you can test it, and then there becomes a place where you can look and say, like, this is what we're saying an account is. This is how we define it.
Yeah, you're trying to take the business language and allow it to live in sort of this much more effective and sort of reusable form, right? And I feel like this goes back to a comment that you just made a little earlier around sort of the people and sort of the people doing this changing a little bit. Y'all talk about at DBT this idea of the analytics engineer. Obviously, folks like data engineers are becoming much of a bigger role in different organizations. Does the shape of the people involved in this process change a lot of what's happening now? And especially, is that another factor that kind of gives rise to DBT?
Yeah, I mean, I'm going to give you a wacky example just because it's the one that always jumps in my mind first. My partner works at a hospital here in Philadelphia. And there's a data team at the hospital. And when she needs requests about, so she's a pharmacist. She's a special type of pharmacist called an infectious disease pharmacist. And the way she operates, she works with doctors who want to prescribe the hardest core antibiotics for like any ailment at all, just to make sure that they kill the bug, right? And so the problem with that is if you do that all the time, you breed antibiotic resistant bacteria and you have like a big problem. And so it's her job to say, like, do you really need that antibiotic, or could we use this antibiotic instead? So she has to run these queries every now and then and figure out how many times do we prescribe this antibiotic for this infection over the past 6 months, and who do we give it to and in what dosage? So she'll make a request like that of the centralized analytics team. And we'll say, okay, we'll get you a data set. And they come back 6 weeks later with an Excel spreadsheet that like is totally inscrutable. Like the columns don't make any sense. There's no sense of provenance. And more often than not, it doesn't actually answer the problem at hand, and the moment has passed. So what we started doing was we did SQL Sundays for a couple of weeks in a row, where I started teaching her how to write SQL, and we spun up like a SQL Server instance on my laptop so she could get familiar with like how to write SQL, so that she could just plug it into the database, run these queries herself. And to me, that feels like sort of the exemplar case of the analytics engineer to be. I think she's got a little further. We haven't gotten to Git yet, but like I know she can get it. But it's that path of like, you have all the domain knowledge, like you know how to formulate the question, you know how to validate data sets, and you can like look at it and say, no, we're missing something obvious. Like I would expect to see this data point that's not here, or this is way too low, this is way too high. And so it's really to me about the domain knowledge, and it's such a good crystallization of it. It's like, yeah, pharmacists should be able to run the queries to get pharmacy data, and like the person doing this modeling should probably be a pharmacist.
So this brings up a couple of things. One is the notion that I've been talking a lot about called a knowledge scientist. And for me, the knowledge scientist is somebody who has more of those generic type of capabilities, and they're not domain specific. And I think what you're talking about, like this analytics engineer, they're more about, I know the domain, but I also know kind of more, I'm more technical. I want to touch on that, but I also want to, this is also brings up to the very hot topic going on right now about data mesh. I want to chat about data mesh in a second, but so is it a valid expectation to think that we're going to have folks who know the domain to become technically savvy enough to actually go do stuff with the data? Or what I believe, and this is what I'm pushing, is like this whole the knowledge scientist, which is the person who is able to go understand a business, right? I may not know pharmacy, but I know how to ask questions and extract things from them. I'm a people person in that aspect, but I'm also a geek, and I can go talk to the data folks and go present things around. And then when I believe I got enough information, let me go present it to that pharmacist and then go kind of get that feedback, and then I can translate it back, because I don't think we're going to get pharmacists to become SQL experts all the time, right? I think it's more feasible to say, well, hey, you're a data scientist, or you say you're a data scientist, but you are really spending your 80% of your time cleaning the data, when cleaning the data really is not just, oh, there's extra spaces in date transformation. It's like trying to understand what this person meant and what this is in the data, and represent that in a transformation, which could be in SQL and stuff. So all of this, my rambling here is, I think it's more about having a knowledge scientist, which is not knowing the domain, but who knows how to go work in the domain. And there are people persons versus having somebody specific in that domain. Or what are your thoughts about that?
I think that's fair. I think this is like a sort of no BS conversation, right? So what I'll say is scientist is too grandiose for a lot of what happens.
Oh, well, the only reason I'm calling it a knowledge scientist is because there's already this thing called a data scientist. So we got to keep it up for marketing purposes. But
and that's too grandiose. Like so much of it is counting stuff. And if you can just like count stuff effectively, you're in the top 1% of high performing analytics organizations in the world. Like most organizations can't effectively count things. And yeah, so often it's, I mean, I think the point you made is so stellar. It's like the hard part a lot of times is understanding how the data is recorded, because we see this in our own data. It's like really challenging to make any sort of inference from data, even if you're just counting stuff, unless you appreciate all the context about how those data points got in the warehouse and like when they're tracked versus when they're not tracked, and for who, and is it on-prem or is it self-service? And it's like, that's such a mess. And that is sort of like almost a research type role. I buy that thing you're saying, but it's domain centric, right? If it's marketing data, you need to know a lot about what the marketing strategy is.
So I think this is the interesting thing about the whole data mesh kind of conversation that's going around, which is like, oh, have your domain, the folks who know the domain, let them be the owners of the data. And I think you'll have a data team for that domain, and then you'll be able to go have folks who will be those analytics engineers who know the domain. But my other thought, I was talking to somebody else the other day, is like, well, people want to go probably hop around an organization, right? So otherwise, I'm just stuck in this particular domain. So I think it's also an interesting kind of career choice where you go with it.
Well, so we have I think a data team of exactly one person today. Given that a lot of us are familiar with analytics, we have a big emphasis on self-service. We like write our own models. The thing we're really trying to lean into is one of the things that a lot of people in the DBT community talk about. It's providing data as a product and not as a service. And so we have a centralized data team, and there's sort of a partnership model with different parts of the business. And we try to be really careful about the asks that we make of, I'm going to say the data team, it's one person today. But the asks that we make and how we ask them, and when she says, yes, I would love to help you with that, or when she says, that's not something we can help with right now because we're building this sort of product to serve this particular use case. And so I think in that model, there's a real opportunity for you to be like, it's like design. We have a design team, and there are product designers that work on specific products. There are folks that work on a sort of component library that's shared across every product. And it really feels like the same thing for data. Like sometimes you need to be working on the sort of centralized core thing itself and making sort of platform investments. And other times you're going out and doing more like feature development and like solving one particular problem or helping someone solve one particular problem. I think that creates the opportunity for variety and sort of day-to-day work.
So Drew, I know that we've talked about some of these different roles. We've talked about sort of the role of SQL and how that's a key part of what DBT is kind of building around. How do you think about other types of either languages like Python or things like that, or non-SQL sources, right? Maybe this starts to get into the future of DBT a little bit. Like, how do you think about sort of the broader data landscape as it relates to transformation?
Yeah, I got my start in 7th grade writing Python, making a Python 101 calculator, 1 + 1 = 2. That was a lot of fun. I love Python. It's because I love Python that I can say with all the goodwill and charity that it like really is very bad for this data transformation type of problem. Like when I see people doing lots of pandas stuff in Jupyter notebooks, and I saw a talk once at a conference. It was like, here's how you can run notebooks on a schedule to do your nightly ETL. Here's how we scaled it out to the entire very large organization. I just kept going like, no.
Then you're trying to go, that's the semantics, right? The meaning of this data that ends up is being hidden in some code that is not even documented.
Drew,
Totally
I
like
have a lot of Pythonista friends, and they're crying right now from what you just said.
Yeah, and listen, I was an R hater for a while. Like I used R in college, and I thought this doesn't work how I think programming languages should work, and I hate it. But I can appreciate that there's, from my perspective, actually a lot more, let me say, like consistency in how people solve a lot of these problems with R than there is at all in Python. And Python just continues to feel to me like the Wild West for a lot of this work.
Are you saying that all transformation should now be in, like, all data should be tabular and all transformation should be in SQL?
Well, okay, here's really what it comes down to. And this is one of the sort of big challenges when we think about communicating the value of DBT to people, or your first experience using DBT. Like, you need a warehouse, you need a data loader that's constantly loading data into the warehouse, and you need some sort of BI or analytics like capacity. Because if you're doing like a dinky demo of like data transformation, you get a CSV file, you have like a Jupyter notebook, and you're like, look, I ran the notebook, and then it spit out this different CSV. But the reality is, when you're doing BI or analytics, or even like data science, almost feels different to me, and we can talk about that more if it's interesting. But like when you're solving these BI and analytics problems, it's really just like count stuff correctly over time as the data changes. And so to me, SQL is so beautiful because it's declarative, and you just say, this is what I want the data set to look like, and then it looks like that. It doesn't mean that you can't do that in Python. You absolutely can do that in Python. Doesn't mean you can't do it in R. You absolutely can. People do with a lot of success. I just think SQL is like a very elegant way of doing that.
That's
successful to many.
Yeah, that's a really interesting distinction. I haven't really thought of that way. Sort of like I wrote down here, like analytics pipeline versus more of your true sort of data science pipeline. I think that maybe in recent years, especially with the advent of like Spark and things like that, right? You see a lot of conflating those two things, right? Like ML, AI, BI. Oh, they're all 2-letter acronyms, right?
Yeah. Yeah, totally. It makes me think about, oh, well, go ahead.
No, I was going to say that the reason why you like SQL is because it's declarative, and that's why you want to go write these transformations. And I 100% agree with you on that. But I think we should abstract it more. It's like we need to have is declarative languages to go do these transformations, right? So we just not have a programming languages and just be declarative about that. But then it's like, can you do everything in SQL? No. So what is the next thing? What are the different types of languages? I mean, and not to get too academic in here, but I think like data log is like the ideal transformation language over there. Right? Like, honestly, I mean, if you look at any single query language or rules language, I mean, data log is a rule language, right? You can, I mean, in database theory, we always compare the expressive powers by reducing it to data log and see, oh, this is relational algebra is non-recursive data log plus negation, right?
What's Prolog? Is Prolog like Datalog?
No. Datalog comes after Prolog. So Prolog is logic programming languages, and then Datalog is a subset of Prolog, right?
Datalog. Yeah. Well, okay. Here's what I would point to primarily. I think that SQL is accessible to many in a way that arbitrarily complex Python is not. I can't speak to Datalog personally, but what I can tell you is the really wonderful thing about SQL is that it works in a client-server model, and you don't need a runtime on your personal machine where you do development to execute it. And so a really big challenge with getting DBT out into the world is that Python environments are bad. And like Mac Python environments by default are especially bad. And Windows Python environments I don't want to talk about because I'm going to like refresh my drink if we're gonna talk about it. So like that to me is really the other half that's really important about SQL. It's like you don't need the runtime on your computer. And I can tell you that some of the developments happening in and around the data warehousing space point in the direction of like you writing code in a language that's not SQL that still gets run on a data warehouse somewhere else with like scalable hardware. I guess the other thing is like if you're doing a transformation on a terabyte of data, it really is not fun to download a terabyte of data, transform it on your machine, and then put it back in the database. That's the cool thing about SQL is you can tell the database, like, just go do this, please. If you do that with Python or R and you have like good conventions around how you write that code, I suddenly have a very small, I suddenly don't have a problem with it anymore,
Okay. Well, I think so. I'm still kind of concerned here that the world will just. Well, I don't know. It's not that a concern that the world just will be SQL and that's it. Because I'm like right now we're seeing this big popularity about graphs, and that's my personal background, right? We want to go do all these transformations from relational to graph, right? And yeah, we could use SQL for that. But then we're doing from graphs to another graphs, and then graphs to relational. We're starting to see all these different data models. I mean, JSON. Like, how do you go do transformations using APIs, JSON and stuff? I mean, I guess you put them all in Snowflake and you can go query this together, right? So
I mean, that it's a non-issue in Snowflake. I think other databases have more mixed support for like unstructured data. But the other thing I point to is like, you know, recursive CTEs, you can like traverse a DAG in Snowflake now, I think. It's something that Postgres could do for kind of a long time. I think the set of things that you, if we're talking about like should versus can, the set of things that you can address in SQL is growing to be most of the types of things I would care about in transformation capacity. Should remains an interesting question that we could talk about. Yeah.
Perfect. That's the quote here. You can do a bunch of stuff in SQL. The question is, should you do this all in SQL?
But I think probably just from this conversation, the bar of things that you should do is actually pretty dang high in my opinion. And I maybe get the sense that you're placing the bar a little bit lower, which is fair. That can be like a personal preference thing. And like, no, I do. There's a lot you can do in SQL.
No, actually, I think if your source is a relational database, you should do everything in SQL, and you can do everything in SQL, and you should do everything in SQL. My point is I don't have, my source is not a SQL. It is JSON, it is XML, it is a graph, it is some other object oriented type of database, whatever. It's like, okay, so then we go transform it into relational, so I can do it into SQL, right?
Well, but so that's sort of like a solved problem in my opinion, because there's all these data loading tools or paradigms. If you use like just say Fivetran or a tool like that, you can just slurp the data out of whatever source and load it into Snowflake in a sort of, in the worst case, it's a single column that has an XML blob in it. And I'm pretty sure Snowflake has capabilities to, you know, parse out an XML blob. And like, is that fun to do? No, I don't think that's fun to do. But does it make more sense to do that sort of on read versus on write in SQL instead of Python? Like maybe we could have
no. So I'm completely with you though. Like it's definitely on read, you want to do it, but I'm just like, maybe not SQL is a thing. Like if you have an XML thing, maybe you want to go use an XML like XQuery or something. I'm not stating to go do that. I'm just like, the point is, it's like the whole world is just SQL, and I've already seen some comment here in the chat. SQL is a universal language of data. Okay, well, I think we'll have some interesting conversations in the live chat after this.
Yeah.
By the way, I told you 30 minutes fly by. Look at this.
It's really quick.
We got more to talk about, but
yeah,
let's wrap it up with some takeaways. Tim, you want to go first?
Yeah, sure. So I think there's been a lot of great takeaways here. I mean, one of the things that I'm thinking a lot about is this sort of distinction of the analytics pipeline and sort of what you're doing to power, like what you said, Drew, like the sort of the, you know, you're constantly loading data into the warehouse. You've got this BI tool, you know, you want like a really sort of declarative and predictable and reliable way to approach that. And it seems like the SQL-based approach is really powerful there. And you think about sort of your data science paradigm as being connected to that, but potentially that's where some of the additional tooling comes to play. So it's got me thinking a little bit about like smart architecture choices and how things like DBT come to play to help you make some slightly different choices than maybe was sort of buzzworthy a couple of years ago. And I think this is moving in the right direction. So that I think that's one of my big takeaways here.
So I got a couple takeaways. One is, transformations, they need to be declarative. We need to stop using Python or a program language for declarative, the right transformation. So that's key. And that's what I love about DBT. And then I really find this interesting about the whole kind of analytics engineer and how like you have folks who are kind of they do their analysis, they know the domain, they kind of know already a bit of SQL, or they can learn it. They should be the folks who are doing those transformations. And I kind of see the balance of, is it that type of analytics engineer who actually knows a domain, or what I've been calling this knowledge scientist who can adapt to different domains? And I think that's an interesting trade-off. And then I like this question is, you can do a bunch of stuff in SQL. The question is, should you? But the bar is already pretty high. So, well, to wrap up, Drew, 2 questions. 1, what's your advice? Yes, very broad, open question. And second, who should we invite next?
Yeah. I tell everyone to get a 10-foot long USB cable for charging your phone. It's changed my life. I sit in bed, I look at Twitter, and then, I don't have to move to make sure it's charging.
That's a really good piece of advice. That's
it's the key to
I'm gonna
success.
hop on
in
Amazon
business.
right now and buy one.
No, like less
Convinced.
than $10. It's just so recommend it. Check out DBT if you haven't heard of it before. If you like it, I'd love to talk to you about it. If you're not a fan or you feel differently, I'd like to hear your opinion too. I think the person you should invite next, we sort of skirted around this a little bit, but I'm really interested in a lot of the heat in the orchestration world. Bit of a misconception. People think that DBT and Airflow or tools like it are competitive, but I really don't think that's the case. I think they work well together. So I'd recommend maybe some from Dagster or Prefect or some of the other folks out there kind of thinking about orchestration. I'll tell you one name, Nick Schrock from Dagster is a good person. He might be interesting to have on.
Awesome. Well, Nick, if you're listening, or we're going to definitely send you the podcast, you're on call. Hope to see you here.
Great suggestions there.
Just a quick reminder, on March 25th, we're going to have our Data.world Summit at 11 o'clock Central. We got speakers from Snowflake, from Booz Allen, from LinkedIn, from Fivetran, from the Zebra Data Kitchen, and also Fishtown Analytics. And also next week, we have a fantastic episode also with Michael Murray, who's the president, and Brett Harper, the CDO of Wunderman Thompson Data, where we're going to be talking about Identity Graph, the new Customer 360. Drew, thank you so much.
Cheers.
Thanks for having me on.
Great having you here.
Cheers for DBT and 5 years, and for having declarative transformations.
Declarative. Oh, I thought we were already drinking. Sorry about that. Cheers to that. Thanks.
Cheers.
Getdbt.com, open source. So it's not salesy, it's open source.
Open source.
All right. Cheers, y'all.
Yeah.